In this video, I will show you how to use TEtrimmer GUI to curate your TE library. I'm Jiang Zhao from FTH Ahn University. So TEtrimmer GUI is designed for two purposes. The first, you can use it to inspect and improve your TE consensus library or sequence from any software. For example, you want to check your TE consensus library from EDTA, from repeater modeler, you can do that. And secondly, you can use it to check and improve TEtrimmer outputs. Of course, from the name, it's called TEtrimmer GUI, Graphical User Interface. It's initially designed to check and improve the TEtrimmer outputs. So first, we'll start how to use this tool to inspect and improve your TE consensus library. Before you use it, you have to clone from TEtrimmer GitHub. You find this folder is called TEtrimmer GUI. The code in this folder is totally independent with code in other folders. You can only copy this folder, clone and copy this folder to Windows, macOS, or Linux. So you do not need to install WSL. It can run natively in the terminal of Windows. For this TEtrimmer GUI, it only needs Python, so no other required dependencies. You can start this TEtrimmer GUI by command line. You use Python and pass to TEtrimmer GUI to this folder you download, and then it's one file called TEtrimmerGUI.py included there. Then you use dash consensus lib, C lib, to your consensus TE consensus library FAST file. Then use G to your genome file and O outputs directory. When you first start it, it will initialize and the first time it will automatically to install the Python packages it requires. It might need several minutes for it, and then it will pop up to this window because TEtrimmer GUI uses a CDD database to check TE protein domains. If you click yes, of course you can click no. When you click yes, you can see from the terminal there will be a progress bar to download this database first. At the meantime, you can still run this TEtrimmer GUI, but the CDD database checking function will not be available. So for the downloading process, I think based on your network connection, it will take around 20 minutes. And after that, you can restart your TEtrimmer GUI. Then you can use this database to check your TE consensus sequence. Later I will show you. So after that, it will show you this window. You don't need to care about TEtrimmer cluster, the low copy, and the skipped. So those three buttons is designed for check and improve TEtrimmer outputs, because currently you only use it for your consensus library. So you click here, consensus library will show the sequence number. You click this number, will show you this window. So all your TE consensus sequence will be listed here, and behind each consensus sequence, you can see several buttons which correspond to different functions. So later I will show you one by one how to use them. And first, I want to show you T8. So T8 is a package that you can use to generate a reporting plot for your TE consensus sequence. For example, blast plots, coverage plots, self-dot plots, and so on. So different with the original T8 package. So the function integrated here will generate interactive reporting plots. For example, you want to check this DNA elements, you click T8 here. It will give you 4 plots. So first is blast plots, and the coverage plots, self-dot plots, and here the CDD protein domain checking plot. When your mouse stops somewhere, it will definitely give you the precise location for these hits. You come back to the CDD database. If the CDD database is available and there is TE proteins exist in this sequence, you will see some result here. Otherwise, there's no results. And then come to the blast. Same for this sequence. You can click blast. 2 files will pop up. The first will blast the text. So this is the text results that contain all the blast hits, but not the sequences itself. And then is the FASTA, is the corresponding TE sequence corresponding with each blast hits. And you can modify this blast function from setting menu. You can modify, for example, the blast E value, and you can also modify the max hit number for the blast. Because for some TEs, there's many copies in the genome. For example, sometimes you will have over 1,000 copies. That means you can find thousands of blast hits. So it's not reasonable, it's not necessary to take all the copies out from your from the genome. Probably only need the top hundreds. In case, for example, you only want 100 sequence from the blast hits, you enter hundreds. If you want modify, yes, you want 200, you can change this to 200s. TEtrimmer GUI will sort this T sequence corresponding with the blast hits and choose the top 71. You can see top long hits number for blast. If you choose the top 70 longest T sequence, and for the rest of the 30 will be randomly selected from the blast results. Please be notes here. In here, it's only the sequence itself. When you double click it, it will open the FASTA file via Alivio, but Alivio is also integrated into TEtrimmer GUI. You can see that the files are not aligned now. You have to align your files inside Alivio. You can click align and realign everything. You will have these results. You have to realign your T sequence in Alivio. And the default alignment software in Alivio is Muscle. I highly recommend you to change it to Maft, because Maft is much faster. You can click align and change default align the program. You can install Maft on your local computer and type this here and set it to the default aligner. So this is also depend on the performance of your computer. This can dramatically decrease your the alignment time. So after alignment, the second I want to say is extend. So if you want to extend your multiple sequence alignment, please be aware the extend function only be available after the alignments of your sequence. If you don't know why we need to extend the multiple sequence alignments, please go to my another video that I gave an introduction about the TEtrimmer background. There I introduced what is manual curation of TEs and the detail of the process. Simply speaking, because we need to extend the MSA to include the potential boundary of transport elements. When you click this button, it will show here. You first indicates the left side extension size and give you, and then the right side. In here, I said I want 2,500 extension for the left end and 1,000 for the right end, and then we'll give you this file. Then you double click it, and this will be opened by Alivio. Please beware again. So this is the FASTA file before the alignments, multiple sequence alignment. You have to align them in Alivio again. After extension and multiple sequence alignment for this file, then I want to show you the multiple sequence alignment cleaning functions. It will be remove gap columns, correspond this button, and crop under by gap, and crop under by divergency. Someone may be asked how to understand these three functions. Like I said in the last slides, and please refer to my another video that I introduced the TEtrimmer background. I gave a very detailed explanation how to understand the multiple sequence alignment cleaning provided by TEtrimmer. So first, let's start to clean the remove gap columns, because after extension and multiple source alignment, many gap columns exist in the MSA. So the first step is to remove them. TEtrimmer GUI integrated a new algorithm to clean the gap columns. It can very efficiently remove the gap column from left side, from here to here. And there are several criteria used by this function. First, if you check if the gap exists in this column more than 80%, if you remove this column directly. And then we check the columns that the gap occupy only more than 40%, for example here. And if you check the predominant nucleotides, for example, there is adenine, but adenine adenine is predominant nucleotide, but it's more than 70% of all the nucleotides in this column, then this column will be kept. In case that adenine is less than 70%, then this column will be eliminated. Then it will also check the columns that if there is less than 5 nucleotides in the column, this column will also be eliminated or deleted. You can also set those parameters in the menu bar. These, for example, clean column threshold, it corresponds with here, and the similar check gap threshold is here, and the similar threshold is corresponding with this, this nucleotides percentage. Here, this mini nucleotide number is corresponding with this one. So after gap column cleaning, then you also need to clean the rows of the multiple source alignments. First, you can choose to use crop and by divergency. Simply speaking, the entire multiple source alignment will be converted to a proportion matrix, and for each line of the matrix, so TEtrimmer GUI will generate sliding window from both ends and move nucleotide by nucleotide or position by position until the sum of the proportion is greater than a number. So if you really want to understand this function, I also highly recommend you to see the other video, TEtrimmer background introduction, or go to our TEtrimmer paper. There is a detailed introduction to show you how to understand this. And same like to remove the gap columns, there's two options parameters you can modify from the menu bar. The first is called crop and divergency thresholds. This is the proportion, and the second is the size of this sliding window. By default is 40, so this is a proportion number. If the set is to 40, then you use 40 multiply 0.65. That will be the minimum proportion number, the sum of the minimum proportion number. For example, if the sum of the proportion is greater than this number, then it will stop. All the positions that is checked by this sliding window, that will be eliminated later. By this, you can from this, very messy multiple source alignment to come here. So cleaning multiple source alignment can very easily help you to find the boundaries. The second cleaning function is crop and by gap. So this one will not convert the multiple source alignment to matrix, proportion matrix, but take the advantage of the gap column. The gap informations exist here. For example, those rows we want to remove them. So TEtrimmer GUI, this function will check them row by row. For example, in this row here, this corresponds with here. It will also create a sliding window. It will go nucleotide by nucleotide and stop until the gap number included in this sliding window smaller than a number, your setting number. You can modify the parameters in the menu bar. By default, this sliding window size is 150. Here, this is also a proportion number. You use 150, modify this proportion number. In this case, it's 7.5. That means if the included gap is smaller or equal than 7, it will stop. All the positions scanned by this sliding window will be eliminated later. So this is only one row. Think about that. So this will check row by row from two ends of these multiple six alignments. Finally, we're from left to right here. So combine those three cleaning functions, you can very easily to clean your multiple six alignments of TEs in TEtrimmer GUI. Then come to consensus button. Once you have the multiple six alignments you want use, then you can click this consensus button. It will generate two files. First is CI align PNG, and then the second is the consensus sequence correspond with your multiple six alignments. If you double click here the PNG, it will pop up this figure. So this will give you a general overview how your multiple six alignments looks like. So now I will show you how to use TEtrimmer to check your T consensus library that could derived from any other T de novo annotation software like ETTA, repeater modeler, or any other software. Once you have the T consensus library, you can use TEtrimmer GUI to check and improve it. In my case, I use the -consensus lib option to indicate the test input FASTA file, and here indicates the genome and the output directory. And you click enter, it will give you this window. So you do not need to care about these three buttons because they are used to check TEtrimmer outputs. You only need to have a look about the consensus lib and give you a number, how many number exists in your T consensus file. You click it, and all your T consensus sequence will be shown here. For example, for these DNA elements, you can double click and have a look. This is a single TE sequence. You can have a look, quickly have a look by T8. Later will pop up in your default browser, and to hear this interactive plot. Here you can see there's many full-length blast. Probably this is not intact, probably only partially cover this DNA elements because there's many blast, full-length blast. And we can do blast. So two files here. So this is the direct blast output file. And this one is the FASTA file, the T sequence derived from the blast his. You double click, you can open it. So this is before alignment. You have to do multiple six alignment inside AliView. You can do rely everything. Then you save it. Yeah, now you have to extend your multiple six alignments. Please be aware the extend function only be available after the multiple six alignments in AliView. Let's say for the left end we want to extend 2500 base pairs long. For the right side we want to extend 1000. You can double click, open it. So this is definitely before alignment. You rely on everything. So here I highly recommend you to install Maft on your computer and use Maft rather than Muscle to do alignment here because this is much faster. The Muscle is also good. I mean, it's accurate, but takes a longer time. You can see after the extension and multiple six alignment, you can already see the boundary. Here this is the potential boundary for the left end. Here this is the right boundary, but there's many gappy columns. You can use crop gap, clean column. It's telling me I have to align them. Oh, I have to save it. Realign everything again. Yeah, I forgot to save it. Then save to do clean column. And double click this one. You can already see all the cap columns are eliminated by this function. So quickly by this, you can have a look. So here this should be the boundary. You can select and delete it. Delete the selected sequence. And delete sequence. And save it. But you can already also see there's some lowly conserved regions. The sequence is hidden inside, and those sequence we want to keep. We can use crop end by divergence to do that. Double click again. It's much clean than before. So now, when you are satisfied with it, you can also check it the multiple circle line by T8. Let's do that. So click T8. Yeah, because we'll check the CDD database. Yeah, sometimes it takes a longer time. You can see here, yeah, this is a Forlorn's blast, and we also find one protein domain. We also find the TI elements. So after the extension, you'll find the right version of these elements. To compare it before, this is after improvement by TEtrimmer GUI. Then you can generate a consensus sequence. Yeah, like I said, this is the PNG file. It gives you a plot to show you the overview for these multiple sequence elements. Looks clean. This is just the new consensus file. Yeah, you can see some N here. You can, yeah, if you do not want this N, you can modify the parameter here, the modify function parameters. So here's this consensus generation threshold. You can, for example, decrease this number. And now you can save your consensus file. I also highly recommended you to save your multiple sequence alignments. Meanwhile, then you finish the check and improve for these DNA elements, and you can do for all other elements. Then this is all the steps that you can use TEtrimmer GUI to check your T consensus library from any other software, not from TEtrimmer. But of course, you can also check its T consensus library from TEtrimmer. But you know, there is a special outputs from TEtrimmer that is, includes the multiple sequence elements. That means you do not need to do that in TEtrimmer GUI, then can save your time. So later I will give you introduction. Then come to the second point, check and improve TEtrimmer outputs. And before that, I want to give you a general overview how to understand the outputs of TEtrimmer, because this is the basic how you can use TEtrimmer GUI to improve it. When you finish to run TEtrimmer, you will always have several folders and several output files. For the top 3 folders, you do not need to care them so much. So classification, deduplication will be the folder that stores the temporary files used to do deduplication and the classification. And the multiple sequence alignment, normally this folder will be empty. So, but if you plus debug option during the running, you will see lots of files there only for debugging purpose. I think a faster file for your input T consensus sequence, your library. For each of the T consensus sequence will be separated to a single file and stored here. Then it's the most important part, it will be TEtrimmer for proof curation. I will come back this later. Then TEtrimmer consensus merged faster. So TEtrimmer will also give you a TE consensus library after the analysis. So merged means after deduplication. Then the TEtrimmer consensus faster. This all the T consensus sequence generated directly from TEtrimmer that before deduplication. You can use this one directly for your genome masking. Comparing with your input T consensus library, and the quality is already high, much higher. But I have to say, comparing to the traditional manual curation, for some case you still need to improve it. So this is the reason why we introduced the TEtrimmer GUI. You can use TEtrimmer GUI to check your outputs and come to the gold standard traditional, manicuration level results. Then sequence name mapping, because the TEtrimmer do not allow the special some characters, for example, the forward slash and the hashtag and so on. It will convert all those symbols to underscore. You can find your old names and new names pairs in this file. And then the summary file. In the summary file, you can find, after TEtrimmer analysis, how many plus numbers found here, if the LTI exists or TI exists, and what's the evaluation results in the summary file. Then come to the TEtrimmer for proof curation folder. We click here, it will show you several folders again. You can see some folders begin with annotations. It's perfect goods and check recommended and check required. And one is called cluster proof curation, and then slow copy and skipped. So first, I want to show you the folders begin with annotations. TEtrimmer will assign an evaluation to each output. For example, when you click goods, it will show you all the output files. Someone may be confused, why there's so many files that have the same name, for example, LTRRT 1328/01, and for this one there's 4 files correspond with only one name here, and the same for this one. I want to say that I will introduce this later. So here you only need to think that this 4 file corresponds with one T consensus sequence. And you can think about this 4 file to one T consensus sequence. The same for this one and same for this one. Regarding how TEtrimmer to assign and in which case it will be perfect good, I recommend you to look at the TEtrimmer paper. I will not talk about this here. Simply speaking, we'll check if the LTI exists or TI exists and the full length plus number, and if the PFAM domain exists, it will give you an evaluation here. So you can check your result definitely directly into the folder. For example, you check how many perfect here, how many good here. But if you want, for example, you want to modify your results, you want to check them by TEtrimmer GUI, there will be a problem. For example, here, this 1328/01 correspond to one TE consensus sequence, and here T000 or something and 653 correspond with one T consensus sequence. It's highly possible that the corresponding T consensus sequence, they have very high similarity, which means if you check this one, it's not reasonable or not necessary to check this again. To reduce the workloads, so we introduce a new algorithm or calculation to cluster those results. For example, if this T consensus sequence, this 4 file correspond with one T consensus sequence, have more than 85% similarity with this one, those 4 files, the corresponding 4 files will be placed to one folder. So this is why there is a clustered proof curation folder here. There have many, later I will show you, there's many subfolders inside, which means, so all the files exist in perfect goods, need check or check recommended. Each file can be found in this clustered proof curation folder, but this is after the put similar sequence together. Then come to this folder, clustered TEtrimmer for then come to cluster proof curation. When you click this one, it will show you cluster 1, 2, 3, 5, 6, and so on. So each cluster, probably, for example, in cluster 1, you will find all the, it's the same like before. So 4 of those files correspond with one T constant sequence. Here, this is another one. So why these two are placed in class 1? It is because their corresponding T constant sequence share 99.92% similarity. So they are placed in one cluster. Of course, this one can also be found in the perfect or good folder. You can find them. They are put together because they have higher similarity. You can also check they are classified as goods. This also classified as goods. And we also give the corresponding T constant sequence length here. And this is a standard, means this sequence compared with this one have 99.92% similarity. So during the checking means you only need to choose one T constant sequence from each cluster. That will be sufficient. I need to check one. Then come to the topic, the very important topic, why there's 4 files corresponds with one T constant sequence or one T constant output. Like I said many times, so 4 files is an PDF file, and cluster.fa, fa, and raw fa correspond to only one T constant sequence. When you double click this PDF file, will pop up this reporting plots. For understanding this reporting plots, I also recommended you to see the other video. It's called TEtrimmer background introduction. I already provided a detailed introduction there. Simply speaking, you can compare what's the difference before and after TEtrimmer analysis, and to see if there is LTI exists or not, if there's TIR, if the boundary definition defined by TEtrimmer is right or not. And based on that, you can quickly to evaluate if this output is you are satisfied or not. Then come to, it's called cluster.fa, this file. Yeah, please do not mix up this cluster with the folder cluster. So this is two totally different concepts. So this cluster means the clusters inside the multiple source alignments. Like I said before, so because the similarity amongst the different T subfamilies are very high, so this is a multiple source alignment file, but it's only after you have an input T constant sequence and after blast and take the corresponding T sequence and do multiple source alignments, which means the multiple source alignment before clustering and before extension. This is the very, very beginning results. Why I keep this one is because, for example, if you are not satisfied with the results, but you can come to the original results analysis, beginning of the analysis, and do clustering by yourself, then you can do extension by yourself in TEtrimmer GUI and get your satisfied results. You do not need to do blast again, and you do not need to cluster them again. Then come to raw. So this is also a multiple sequence alignment file. It's a faster file. Now this is TEtrimmer will do clustering based on here and do extension and do, but this is before the boundary definition. And you can see here, so this is before the cleaning of the multiple source alignment and before the boundary definition of this TE. So why I want to do this is because based on the report plot here, you think the boundary definition is wrong, then you can come back to this file and you can quickly to modify the boundary here. And then come to the last master, the multiple source alignment file is also faster file. So this is the multiple source alignment of TEs used to generate the final T constant sequence. This is the final file after TEtrimmer analysis, after clustering, after extension, after cleaning, after the boundary definition here. Then this is explanation for those 4 files. Those 4 files correspond with 1 TE consensus. If you are satisfied with this, so before I said there's a consensus button, you click consensus, it will generate a consensus file and save it. And because this sequence have more than 99% similarity with this one, you only need to check this one and skip this one. To give you a basic overview how similar those sequences are, because in each cluster folder, it includes many files or many T-consensus sequence. We provided multiple sequence dot plots. Based on these multiple sequence dot plots, you can see how similar those sequences that are included in one cluster folder is, and where's the difference. Yeah, this is the introduction for how to understand TEtrimmer outputs. Then come to how to use TEtrimmer GUI to browse, to improve or modify your TEtrimmer outputs. Come to the gold standards, the T-consensus sequence or library. So like I said before, you can copy the TEtrimmer GUI folder to any place, Windows, Mac OS, Linux. You do not need to install WSL. You only need Python. And to run this command line. So in this case, you change this option to -i to -input. And this is the path for this folder, TEtrimmer for proof curation. You copy this path to here. So all the files exist in this folder will be recognized by TEtrimmer GUI. After that, then you use these 3 buttons, TEtrimmer clustered, TEtrimmer low copy, and TEtrimmer skipped. So TEtrimmer low copy and skipped, you can also refer to the other videos, TEtrimmer background introduction. Some T's are classified as low copy and skipped. You can also check them here. So here I will not emphasize them. Then you come to TEtrimmer clusters. You click, this show how many numbers of clusters it have. Click here, it will show you the different clusters. You cluster 1. It will show you all the sequences exist in the class 1. You can check all the files by double click the corresponding file name. And same like before I said, you have extend function, T8, multiple sequence alignment, cleaning function. You can generate a consensus sequence. So by this way, you can very easily and quickly to check the outputs from TEtrimmer. So now I want to show you how to use TEtrimmer GUI to check your TEtrimmer outputs. So first I want to show you the outputs, what I have. Like I said, here's this classification and deduplication. You do not need to care so much about it. So here's this temporary files. And here's a multiple sequence alignment. It's empty because I didn't add the debug option when I run TEtrimmer. Here's a single faster file, includes all the inputs T consensus sequence. You don't need to care so much about that. Here, this is the consensus files. And here is a sequence name mapping. You can see the first column is original name, and then here this is the name used by TEtrimmer. This is a summary file. Yeah. This give you, for example, if the terminal repeat exists, and if this is low copy, give an evaluation, and so on. So let's come to the most important part, the TEtrimmer for proof curation. Here, this is a 4 folder begin with annotations, like I said, with perfect, good, required, check, and recommended check. And all the files exist in those folders can be found from clustered proof curation. I find why we do that, because we want to put similar results together in one cluster. For example, in class 1, there's correspond with 2 consider sequence. Let's start from the command line. Say Python TEtrimmer GUI.py -in inputs. So here this is to the TEtrimmer for proof curation. Here this is the genome, here's the output. When I click enter, give you this window. Now you can find something. So in TEtrimmer cluster you find 31 clusters. There's also some sequence is low copy and some is skipped. Yeah, because before we did connected libraries, so we still find some sequence there. So let's focus on the TEtrimmer cluster. Let's go to cluster 1. You can already see, I said before, so 4 files corresponds to one consider sequence. Yeah, because I think I previously did some analysis here. There's one additional PNG file. Yeah, let's do this one. So here this is 4 files. This is clusters, faster, raw, faster file, and the PDF file. And well, those 4 files correspond to one consider sequence. This one consider sequence. You can first to collect this PDF file and check if the boundary definition is right or not, and check the T8 plots. This is before, this is after, and OF and the PFAM domain plots, and the dot plots before and after TEtrimmer analysis. If you are satisfied, you can check this one. So this is the multiple sequence alignment file. Oh, but I find one here. This should be the first column is included into the final the multiple sequence alignment, but it needs to be eliminated. Here you can do that because it's always start with TGT and end with ACA. Save it, and you can generate. Oh, here you can also check it by T8. Yeah. So here we can see the LTR sequence here. You can also see the coordinates, the location from the coverage plot. Yeah, definitely from the sample plot there is LTR. You can see this from 1, the first nucleotides. We definitely find several coding protein domains. Then for these multiple sequence alignments, we can save it. And we can also generate a consistent sequence for it and save this one. Yeah, because we can say for this sequence it shares more than 99% similarity. We are already satisfied with this result, so it's not necessary for you to check this again, to check this one again. Of course, here there's a dot plot to show you similarity among these 2 sequences. Then this class will be finished. We can also definitely check other classes if you are satisfied. This will classify as good. This is good. You can see before there's no long-term repeats, but after TEtrimmer analysis there's long-term repeats exist. Let me give you an example. Open 2. So this one is a neat check. Let me have a look at this one. Yeah, for this one, probably we're gonna reanalyze this one. Let's say we want to extend this. No, not extend, but check the raw. Like I said, the raw multiple sequence alignment is before the boundary definition. If you think that the boundary definition defined by TEtrimmer is not right, you can quickly come to this file. You think, oh, it should be start from here, from TGT. The definition, initial definition for TEtrimmer probably be wrong. And let's have a look at the end. Should be here, it's ACA. If you are not sure about this, you can quickly come back to here and to generate T8 plot for this multiple sequence alignment. And from here you can exactly know the coordinates, the location for the LTRs. For example, here it should start from 397, 391. Okay, the LTR start from 391. Yeah, 391. And end to 6. Let's have a look at the first 391. We come back to here. 391. 390. This is not right, but we are sure it should from here. Okay, then we believe our eye is not that. So please double check it. Sometimes, even this plot could give you the wrong coordinates, but you can have a look from here. 397. This is the full length plus. You combine this information and this information and combine with your judgments, and you come here to select this sequence, delete it, and then come to the end. TGT, ACA, delete it. Yeah, so as you can see, there's still some sequence that exists. You want to eliminate them, you can save this first. Close it. Come back, and then you can do clean. After cleaning, you can see you can clean most of the sequence that are internal, but of course there's still some left. You can adjust the parameters to check it, but so far it looks not bad. You can also clean them manually. Then after that you can do T8 again. Have a look. I think it's great. So we have LTR here, and from the coverage plot it looks good, and there's domains. We're done for this one. You can generate a consistent sequence. You can also have a look at this one and save it. Of course, and meanwhile, I also recommend you to save the multiplex alignment file. So you will finish for this class 18. Of course, there's many classes. You have to check them. Yes. You can close it. You can also see from the terminal, every time when you do, for example, T8, you do cropping process, it will also shown in your terminal. When you have some errors happens, you can always come to your terminal, have a look if there are some messages.